my student. Yes, it's me again, Madam Gracious Kanzini from Educare Tanzania. Welcome for a continuation of our chemistry session, Form Theory. My students, we are proceeding with our amazing topic, which is Ionic theory and electrolysis, and we are still in our second subtopic, which is all about electrolysis. And today we are proceeding with another kind of selected electrolysis, selected electrolyte. I mean those suggested kind of electrolysis of some of electrolytes. And today, my students, we are going to see the electrolysis of copper 2 sulfate solution with the copper electrode. Now we are going to see the difference. In previous session tuliona hizi selected electrolysis of electrolyte, lakini zote zilikuwa with copper electrode, I mean with carbon electrodes or graphite electrodes. Lakini leo tunaenda kuanza na hii electrolysis of copper 2 sulfate lakini with copper electrode. Now consider the simple diagram here which demonstrates this electrolysis of copper 2 sulfate with the copper electrode. This is copper electrode, as you can see here in our diagram, and it is made up of anode, but this is copper 2 sulfate solution, meaning that our molten state, our solution which allows the current to pass through, is made up of copper solution, while also our electrode is made up of copper electrode. Here we have the pure copper sheet which is at the cathode there. So this is just a simple diagram which demonstrates how the electrolysis of copper 2 sulfate occur with the electrode of copper the same. Now, what are the components within this electrolysis of copper 2 sulfate with the copper electrode? We have the copper 2 sulfate and also we have the water. Now, what are the dissociation of these ions? So, the ion present, you can see at the cathode we have the copper and the hydrogen positive charged ions, but at the cathode, at the anode, we are going to have the sulfate ions and the hydroxyl ions. Now, the migration of ions are as follows. At the cathode, there will be the migrant of copper 2 ions as well as hydrogen ions, but at the anode, we are going to have the sulfate ions as well as the hydroxyl ion. Now, let's just see the concept of discharge of this electrolysis of copper 2 sulfate with copper electrode. From electrochemical series, copper cation will discharge at the cathode and according to the nature of the anode used. Asa hapa ndo tunakuja kuconsider ile factor ambayo inazungumzia the nature of the electrode. So you can see the electrode is made up of copper, but at the same time our solution or our molten which allow the current to pass through is made up of copper solution. So here you can see copper anode will dissolve to form the copper 2 ions into solution. So this copper ambayo inakuwa kwenye anode ita dissolve. Now, what are the reaction going to occur at the anode and the cathode is as follow. Now we have at the cathode, we have the copper. Copper tend to discharge where we are going to have the copper metal, but at the anode, this copper metal it is tend to dissolve to form a copper ions. Inaenda kutenda kudissolve kuform copper ions, kwamba at the cathode tumeona yenyewe imedischarge imeenda kuform metal, lakini at the same time katika anode yenyewe inaenda kudissolve kuform nini, the copper ions. So this is how this electrode or this electrolyte or this electrolysis of this selected electrolyte differ from others. Nyingine zote tuliona with the carbon electrode ambayo tunajua kwamba ni those graphite electrodes. Lakini hii hapa tunaona kwamba ina depend na factor ya nature of the electrode, kwamba electrode na solution they are made up of the same nature. Now, let us see the product. kwamba copper metal will deposit at the copper cathode. Consider the diagram. So you can see those the copper inakuja kudissociate hapa, I mean kudeposit hapa at the copper cathode. So before ilikuwa kwenye anode, lakini tuliona kwenye anode yenyewe ilifanyaje? Ilienda ikadischarge ikaform solid. Ile solid ikaenda tena ikadissolve. Baada ya kudissolve ndo tukaja kupata iron again. So there will be the deposition of copper metals katika cathode electrode, as you see here. Hii hapa imeyeyuka, imedissolve kwenye solution. Baada ya kudissolve inakuja tena ina form hii hapa, inakuwa formed hii hapa ambayo imekuwa deposited katika cathode. Now what are the observation? The first is solution turn blue color due to the color of hydrated copper sulfate. Kwa hiyo solution itabadilika rangi kwa sababu ya this characteristic of copper 2 sulfate, inakuwa blue in color. And the mass of cathode increased due to the deposition of copper metal, kwamba mass of cathode itaongezeka kwa sababu kumekuwa na deposition ya this ya copper metal. Another is mass decrease because copper anode dissolved in solution. Sasa tuliona kwamba ile copper anode ambayo ilikuwa ina exist as electrode ili dissolve. Sasa kama it dissolve means that in one way or another the mass of the anode will decrease. Another is intensity of the blue color of the solution remain the same, kwamba ile intensity ya blue color ina remain the same. Vile vile concentration of copper 2 ions remain constant in the solution, kwamba hata kama kumetokea hii dissolving hii hii deposition of copper, lakini ile copper ambayo ipo kwenye solution concentration yake ina remain constant, haibadiliki, inabakia vile vile. Now my student, let us see the another selected electrolysis of this electrolyte, which is the electrolysis of dilute sulfuric acid with carbon electrode. Now it conducted in the electrolytic cell known as Hofmann's voltameter diagram, kwamba hii electrolysis of hydrochloric ya dilute sulfuric acid yenyewe inakuwa conducted katika kifaa kinachoitwa Hofmann's voltameter. Hii na yenyewe inakuwa different na nyingine zile kwa sababu zile zinakuwa zina involve the electrolytic cell, lakini hii ina involve kifaa ambacho ni Hofmann voltameter, whereby the diluted hydrochloric acid tend to enter here, but here there is a current connection, and here will be the platinum oil which is anode. Lakini pia tutakuwa na platinum oil or foil which is cathode. Now the hydrogen gas will be involved as well as the oxygen gas will be involved. Now let us observe the dissociations, migrant of ions, and what are the discharge nature. Before we move on the dissociation, now what are the components in this electrolysis of sulfuric acid? So we have the sulfuric acid, that is our first component. Another one is water. So in the dissociation means that we are going to have the positive charged ion and negative charged ion. Now the compound is sulfuric acid and water. The cation here we have the positive charge of hydrogen, but also we have the positive charge of hydrogen at water. So katika sulfuric acid tunaenda kuwa na hydrogen as a positive charge ion, lakini vile vile kwenye maji naye yanazalisha positive charge ion. Now an ion, the sulfate, we are going to have the sulfate ions as well as hydroxyl ion. Then we are shifting in other parts of migration, how this electron move. At the cathode, hydrogens, both hydrogen will move toward the cathode, and sodium, hydroxyl ions and sulfate ions will move toward the anode. Now let's see the discharge nature. From the electrochemical series of hydrogen, cation will discharge at the cathode and the hydroxyl ion will discharge at the anode, whereby at the cathode tutakuwa na discharge of hydrogen ions ambayo tutaenda kuform hydrogen gas, lakini at the anode we are going to have the discharge of hydroxyl ion, whereby we are going to have the water molecule, oxygen gas, and those gain electrons. Overall reaction itakuwa tuna 4 hydrogen ions, 4 hydroxyl ions at the reactant side, whereby we're going to have the oxygen gas, water molecule, and the hydrogen gas at the reactant, at the product side. Now, what are the products in this electrolysis of sulfuric acid with the carbon electrode? Now the hydrogen gas will be produced at the cathode, kama tulivyoona kwamba yenyewe inakuwa discharged at the cathode to form the hydrogen gas. Kwa hiyo product itakuwa formed in hydrogen gas at the cathode, but also oxygen gas will be produced at the anode, and water remain in the solution. Sasa ukirudi kule kwenye ile our apparatus which is Hofmann voltameter, whereby we see that oxygen is moved out and hydrogen is involved out at the anode and cathode. So this is how this mechanism occur, though it does not involve the electrolytic cell, involve ile Hofmann voltimeter, lakini tunaona kabisa hydrogen inakuwa involved at the cathode, vile vile oxygen inakuwa involved at the anode. Now what are the observation in this electrolysis? The volume of hydrogen collected is approximately twice that of oxygen, because oxygen is more soluble in water, kwamba volume ya hydrogen ambayo imekuwa collected yenyewe ni mara mbili ya ile oxygen, simply kwa sababu gani? Oxygen imekuwa ni soluble in water. Another is since it involves element of water, now it is called the electrolysis of water, kwa sababu the element of water are involved. But the process continue, element of water will decrease and finally sulfuric acid become concentrated, and once it become concentrated, bali tunaona kwamba this is sulfide ions zitakuwa involved, zitakuwa discharged and so forth. Another electrolysis ambayo imekuwa selected for you to study is the electrolysis of molten potassium iodide with the carbon electrode. So this involve also the crucible, apparatus. It is also does not involve the electrolytic cell. Hii pia ina involve crucible apparatus, whereby the graphite of cathode is there, graphite of anode is there, molten of potassium iodide is like this. This is the heat source, and this is the tripod stand, ina support hii apparatus hapa. Now what are the components? The component in this is only the component is potassium iodide. So if it is only the potassium iodide, now dissociation, the ion present, the compound is the potassium iodide. So at the cation we are going to have the potassium, and in the anion we are going to have the iodine. Now the migrant of electrons or this ion is at the cathode, potassium tend to migrate to move, and at the ion at the anode, this iodide tend to move toward the anode. Now let us see the concept of discharge. Because only potassium cation present, it will discharge at the cathode and the iodide ion will discharge at the anode. Kwa sababu hii yenyewe tunaangalia ni only the electrolysis of potassium iodide, yenyewe haitokei kulingana na dependence of electrodes, other electrodes. So kwa sababu hizi ndio component ambazo zipo, the potassium atakuwa discharged at the cathode and the iodine negative charge atakuwa discharged at the anode. Now consider the reaction. At the cathode here, potassium ataenda kuwa the solid, so ata lose electron, lakini at the anode here this iodine will gain electron and we're going to have the iodine gas. Now overall reaction una take this, we sum with this, tuna plus na hii tunakuja kupata 2 atoms of potassium which are in molten state, lakini tunakuwa na 2 iodine ions which are also in molten state. Lakini baada ya hizi ku undergo the reaction in the cathode and the anode, we're going to have the iodine gas with the we're going to have the iodine gas and we're going to have the potassium solid metal. This is there is a mistake here, my student. Here we're going to have the solid metal and the iodine gas. Now what are the product? The product is potassium metal will deposit at the cathode and the iodine gas will be produced at the anode, kwamba ile potassium itakuwa deposited at the cathode, wakati huo iodine gas itakuwa produced at the anode. Finally, my student, after looking this sum of selected electrolytes, now there is a task for you here to attempt so as you can improve your understanding concerning the whole sessions we have tried to discuss. The question states that describe the products that are obtained during electrolysis of concentrated sodium chloride solution. My student, because I know umesikiliza vizuri, pia umeseto, utarudia na kurudia, itakuwa ni rahisi sana wewe kufanya maswali. It's very simple questions, so go and try to do it, and also go and search some of materials. Don't only remain here, no, expand yourself by finding the different materials concerning with what we have learned here, we have discussed here, so as you can enhance your understanding, and I hope you will enjoy and you will improve your understanding more and more. Thank you for watching Educare TZ. Stay tuned, Educare TZ. I would like to thank you and see you in next time. Bye bye, my student. I know my Form 3 student, you will go through the books and you will go through checking the library books, checking the past papers, different questions, and try to solve it more and more for your benefit. Now, after saying this, it marks the end of our session today. Thank you for watching. Stay tuned to Educare Media for more learning contents. Bye bye, my students. Have a nice moment. See you in next session. Jenny, si uzime. We Jenny.